This is the cam overview for the coin vault pieces. You're going to have a setup that's going to cut out these 6 pieces all at once. A second setup to cut out the bottom cover on a separate sheet to kind of maximize our material usage. A setup for the brass Waterjet coin slot. And the final one, this is still not quite determined whether this window will be CNC cut on the router out of Lexan or it will be laser cut out of acrylic. So the setup for these 6 pieces, you're going to have your work coordinate system at the back left top corner right here. To change from our standard corner, simply just change the bubble, and then let's say if your X and Y are in the wrong direction, you can just kind of go over here and go select X and Y axis. So now X axis, let's say it will be this one, and then Y axis will be this one. So this will be the opposite of what we need to do. So my X and Y axis are pointing the wrong direction for what we want to do. So we're going to go back and make our X axis this segment, Y axis is going to follow this segment, and then our box point's going to be at the top. And notice it's upside down, so I'm going to click on the tip of the arrow and flip it, and then pick that point up again. And now we have our X to the right, Y backwards, Z up, and that's that for the setup tab. Operation type is under cutting. Make sure you select your 6 bodies. You need to actually click on these 6 pieces because we're not cutting out all of these, just these 6 right now. Stock is going to be relative size box with 0.1 on the side offset and 0 on the top. So basically need an 8.5 by 12.8 X and Y dimension piece of sheet metal, and we're cutting this out of a 48-inch by 48-inch sheet. Post process, you can do a comment here. This is going to be program. I'm just going to go 5/26/86 for my birthday. And then the program comment will be 6 sides. Leave that at 0. Click OK. Your tool path, you're going to use the cutting operation. You can copy and paste from a previous plasma cut file or use the template that you've created. But basically you're going to use the built-in .04 plasma cutter that is found in the samples profile under inches. In the sample tool library, this .04 plasma cutter. Cut quality is going to be through on auto, and they're going to be cutting at 120 inches a minute for the lead in cutting feed rate and lead out for the 14 gauge steel. Geometry, you're going to select your 6 surfaces. Tabs, we're going to have a 0.1 inch tab at 8 points. So basically 1 tab here, 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 holding our pieces into our main sheet. And also a tab here and here to hold our inside drops. No tabs on the smaller cutouts. Heights tab, nothing here to change. Passes, make sure your compensation type is in computer. Linking, gonna have a 90-degree sweep in angle, a lead in distance of 0.05. We need a really small lead in so we can get a tool path inside of that small hole for the rivet, and then a pierce clearance of 0.04. The simulation for this should look like this. We're just going to cut the inside geometries first. And then the outside. So this will be post-processed with the Techno CNC Plasma Post Processor as a single file, and you'll cut that on one sheet. The cover is basically going to have identical feeds and speeds and properties as the 6 pieces. We're just cutting this out as a separate piece out of a different piece of sheet metal. So the setup is going to be Pretty much similar. We're going to put it in this corner. You can also put it in this corner. Really just whatever corner works the best for this sheet that's being cut. Sometimes as they get cut and cut and cut and cut, you want to make sure you actually kind of predetermine where you're going to put that work coordinate system for your origin selection out on the table. So we're going to use this corner right here, and then basically same thing, 0.1 on the side, post-process. So this will be, I'm going to call this 526.86.2. And this will be the cover. Click OK. Still using that default 0.04 plasma cutter in the samples library at 120 inches a minute. One tab on the outside. Nothing on the heights, passes, compensation type in computer. Linking the same as before, 90 degrees, 0.05 lead-in distance. Right there. So that's the programming for the last steel piece. Here's a simulation cutting out the holes for the bolts and finishing with the outside profile. Pretty straightforward there. The Waterjet part, the coin slot, that setup, let me spin this around. Cutting our stock box point is going to be on the bottom left corner, kind of the standard corner for most of our cutting operations. The stock is going to have a side offset of 0.04. We can be a little more accurate with our water jet, so we need a stock that's 2.08 by 0.83. Post process 1001 is fine. I'm going to do something a little more unique, because if everybody does 1001, it might be a little difficult finding your file. Coin slot. So that's the setup, and then the cutting operation for the water jet is very similar to the plasma cutter. For the tool, you're going to browse and go into the samples profile water jet, this 0.021. Our water jet kerf width is actually 0.027 to 0.03. But since we're going to do compensation type on the controller, this value right here really doesn't matter that much. For the water jet, we use quality, not necessarily feeds and speeds for the cutting rates. We're going to do medium quality. So these numbers right here aren't even relevant. The settings for medium are going to determine the speeds for the cutting of that thickness of material. Geometry, we're going to put this section, that's going to be our selection for our chains. Tabs, we're going to have one small tab, 0.05 inches in width. At one point, this will keep our part from dropping into the abyss of the water tank and the water jet. Nothing on the heights tab to change. The default values there are just fine. Passes, this number's fine. Left, make sure this is in control. This is where it takes the actual diameter of the water jet nozzle that's set on the computer or the control, not what's programmed in Fusion. Linking on here, we're going to have a 90-degree sweep angle for the lead-in. The lead-in distance 0.035. Actually, I'm going to bump that up a little bit more. We usually want that to be bigger than our water jet diameter, so we're going to go 0.05 on that. Pierce clearance, same thing, 0.05. Let's see if we get tool path. Tool path on our small holes, tool path on our slot, and then on our outside. One thing I possibly didn't spend some time looking at on the plasma cut parts on the linking, we don't need a lead out. I don't know if you caught that, but we don't need a lead out. We just need a lead in. On the water jet, we'll have a lead in and a lead out. We can probably get by without a lead out, but we're only cutting one part. And it is nicer on bigger parts to have a lead out. I think. I don't know. Cancel. So that's the cam operations for the 14 gauge hot rolled steel. So the 6 pieces and the cover, and then the coin slot. This acrylic is to be determined. That will be in a separate video, whether that's going to be laser cut acrylic or CNC router cut Lexan polycarbonate. Thank you. Goodbye.